a phi wave. I haven't looked up, I was just getting ready to look at phi waves, but I believe that this year thing here is going to be a phi wave going. But what's happening is on the magnets, the sun and moon, and I can explain the phases. I'll do that. Antonio and Patricia, I know how the phases work. I've been modeling them for a year. I know what causes the phases. It's a distance in
elevation,
attitude or altitude of the things. And the projection you see from underneath, from seeing it from the angle you see it at. I can mimic it. We can do this all in lab. Anybody can do this. Anybody can sit at home and do what I'm going to tell you. It's not magic. It doesn't take anything. I can make you get all your moon phases perfectly. All you need is a flashlight and a ball. And I know it's not a reflection, but think of it as a fluorescent reaction. It's a phosphorescent reaction.
Yeah, so the light is just mimicking.
It's emitting cold light.
Yeah.
It's reacting with radiation to emit in this magnetic system. So in this magnetic system, what's happening is the sun and the moon. Here's your heart-shaped part of the map, by the way. This is where, if you move your prime meridian right here to Giza, you'll have the Hawaiian Islands right in the cleft here, the place of creation.
Wow.
Where all your volcanoes are.
Yeah.
Also, you're going to notice that your ring of fire, all of your stuff, this is your ring of fire because of the magnetics pushing here. I can explain all of our phenomena mathematically and magnetically. So you have your ring of fire going out. Here's where on your map you would have Russia going around to Japan. Your actual lines.
Can you hold it a little bit higher, Cami? Sorry.
Pardon?
A little bit higher. Yeah.
Yeah.
So
your magnetic numbers that you're reading here, these are all right here. In other words, you're reading a map and these are travel maps even.
Okay, but
the one thing that you're off on here is putting the 360 or the 0 here and then just counting your ones there. Once you do that and fill in the map and then take the equator around for Hawaii, your map will fill in and show that what's happening in South America is pointed right here to Antarctica right here. Australia sits here on the 30th degree and points in where they have the star field here. I had them all, the stickies came off of it. This is Asia, Russia rushing around, Africa doing it underneath. All of the continents lay out, but they out perfect coordinates. In other words, you can read your coordinates. If you make the adjustment, you can take your coordinates and stick them on the map with the latitude lines. That's what, like I matched up latitude lines on them.
Mm-hmm.
And it just changes. Like South Africa is like this, it's bigger. South Africa is bigger than my little thumbnail, but it lays out.
Yeah.
And you're in a mirror image, but it's laying out towards this Australia here, and you're in a mirror image. I'm not showing it very well. Bob, do you guys want Bob to explain?
Hey, Bob.
Summer.
I don't know where you're at.
Hello,
Hi, guys.
Bob.
So, Cami, you wanted to know whether using a drawing program would help you to demonstrate. I don't know. I mean, the way that you were showing us then was clear.
Can you see it all?
Yeah.
Now, it needs to be condensed. The ratio needs to go more like a TV, a 4:3 ratio. But if you squeeze everything in, I think that's going to be...
Yeah, it'll make it a little bit more square. But the thing that really kicked it over for me, guys, is when you look at these 3 node points, right?
Mm-hmm.
These are actually... she showed you that. Where's the double-sided
I haven't
pyramid?
seen it this, but here, you can show them that. I have one right behind you. Right behind you. No, I haven't shown them that.
Okay,
Go
because
ahead.
this is what really did it for me.
I don't know what
The
that is.
pyramids. You remember we talked about the pyramids are double-sided like that?
Yeah.
So you have to imagine this on each one of these nodal points, okay? Except these two would be diametrically opposed, like south poles up
Yeah.
to a north pole up, okay? When you do that, then you start getting these grid lines, all right? This is the magnetic lines. As above, so below. This is actually the star patterns when it's transformed from the ball Earth into just a straight across grid. That's what this is. This is actually a real mapping of the star magnetic lines and also the star patterns above us. Actual coordinates. Okay, that's what this is.
So if you lay in your star fields, lay in Polaris, your planisphere views, here's your planisphere, put the North Pole here, put identical south poles here spinning clockwise and counterclockwise. You have your star fields, but they work like a clock with the moon and the sun each time controlling the exact speed of your star fields, which are luminescence on these two fields.
Right, well, which will actually show up as mirror images.
Which will show up as mirror images.
So as the sun makes its way across,
the sun is going to go in this type of pattern, an egg pattern across, depending on, here's the equator down here, it's actually going to go with this following in an egg, the ellipse that you see.
yeah, and the forces are going.
That's on the outside and on the inside here. But you can actually see where the ellipses and everything are by doing this. Watch this. Let's get you close on here.
Mm-hmm.
See your equator right here? Is in orange, right?
Yeah.
Okay, if you look at 23 degrees where your tropical Capricorn and Cancer are,
Yeah.
they are right where your patterns change. Right here where it goes, this is your 23.5 degrees, is if you pull your pattern up, you'll see where Cancer and Capricorn, they do that. And what's happening is the sun is going further towards them and going lower. It hits that magnetic change right here. It hits right here and bounces back until it hits the break in the pattern here and then bounces back. So it's bouncing back between the two pattern breaks magnetically.
Right, so the
It's
sun
lower
and the
here,
moon
higher
are
here.
literally
Magnetic,
riding on magnetic lines of force or a quote-unquote one-wheeled chariot.
a one-wheeled chariot above you going around. Now the sun is moving faster than the moon, and so I can explain the moon phases by.
But from what you've just shown us, there is no circular path for the sun or moon to take, though. There's a heart-shaped one where you said that Hawaii sits in the.
No. Follow this shape right here. That's just your magnetic lines. Your sun lines are right here. They're the full circles.
Okay.
They do not make the cleft in, but your magnetics do, and your magnetics determine the sun, because it's pulled in an orbit around it. It's a circular orbit because it's a magnetic orbit, so it's not going to make the cleft. But these magnetic lines, which are pulling here and here, are giving us our volcanoes and also your Tahiti Express, which is, your south. All your directions follow your latitude, longitude lines. Your east-west are these lines. That's how they confuse us on the map. Is these are magnet. Your compasses are acting as magnets. So here's your anomaly, South America anomaly. You can
South Atlantic anomaly.
Atlantic. I'm
Yeah,
sorry.
slow down a little bit, sweetheart.
Slow down a little bit. But your anomalies and everything. If you lay the magnetic pattern on top of this, and if you take the pole where they show it's halved on Russian, that make one pole, which splits out the other, you can see where the anomaly splits out and where the two poles are on our magnetic Earth map.
That's right.
I'll show you, I have it.
And so the reason that we have the quote-unquote South Pole is actually at about 67 degrees south, right, is because of the placement of these pyramids, if you will, that are highly charged magnetically. Now, the only thing to this, what this means ultimately, is that Antarctica is literally in two different places. I mean, it's in every place, but there are two bulged land masses, okay, that come out near south of South America, and the other one would be near Australia, okay? Those would be, somewhere in those vicinities would be where these other magnetic poles are, and thus, that is exactly what they're telling us is the South Atlantic anomaly, which they tell us is brought about by the Van Allen radiation belts, which is, of course, bullshit.
Right, and magnetics causes cooling, does it not? Or the other way around, sorry. The effects would cause... I'm sure I've seen lots of stuff with super-cooled magnets, which would make sense if the place that's highly magnetic is very, very cold.
Yeah, but it doesn't necessarily have to be that way, Nathan, because if you have materials made of low permeability, low magnetic permeability, i.e., this stuff, celestite.
What is it? Sorry, I didn't catch that. What was it called?
Celestite. This is what the moon is made out of.
You're screen sharing at the moment.
Uh-oh, you just got muted.
Oops, we're muted.
Yeah, you're screen sharing at the moment.
Yeah.
Oh,
Okay,
okay,
can you
now
hear
we
me?
got you.
Okay, on the screen share, I'm sure we'll do that in a minute. On the screen share, I want to show you something.
Okay, so Nathan, what they just showed was called celestite.
That's a whole conversation. We can stay on it right now.
Yeah.
But I want to show you this magnetics before we
Sure.
go far.
Sure.
Do you remember what we were looking at?
Uh-huh.
This is our Earth's magnetic pattern. Now do you see my cursor?
Yeah.
Okay, take this pole and pull them together, stretch them together.
Uh-huh.
And you'll notice that it's going to pull this pole and this pole. So this is actually one pole.
Yeah.
Pulled together, you're going to have a triangle of pole. In other words, one in the center. This is the same one, but these really are separate. That's their illusion. We have 3 poles.
And that's why everything
Trinity.
is off by 60 degrees. That is also why they had to move the prime meridian from Giza to Greenwich, because otherwise everybody would make the connection between the stars and the star fields and the Earth on the prime meridians.
Everything
All
matches.
this makes
Yeah.
sense with the
Now, if
3
you
and
look
the
at-
pyramids and the up and down and that.
Are you ready? Look at your symbol right here. This is a compass. See how these are clock hands and they move?
Yeah.
That's because the North Pole or the South, whatever pole you call it, and the sun, they rotate around this pole only, but you have 2 other poles right here and right here. But this is your clock face rotating around. Do you see?
Uh-huh.
Here's your circle of the sun, but it's affected by 2 other poles.
It takes a little while to wrap your head around, but it makes perfect sense when you do. I mean,
Oh.
it's like, oh my
you
God.
guys are
Like this picture,
brilliant.
That's
this
what
is
they're...
the last symbol. This is the last symbol.
So the set square that they have on the Masonic emblem is telling you where the other 2 poles are.
Absolutely. And you can read it magnetically on the pattern. It just also tells you how to continue your pattern. And here you go right here. Here's your sun's path around the North Pole, and then you have your other poles here and here. But that's your last symbol.
So let me get this straight. They're hiding
This gets
the
pulled
fact
into
that
one
the
pole
Earth is flat,
apart.
and we have 3 magnetic poles. That's what they're
Absolutely.
That's right.
Yes.
But they've been sold to us as a South Atlantic anomaly. And also, like I said, even if you look at Wiki right now, it'll tell you that the South Pole, and I've talked about this on Globebusters a million times, they tell you that the South Pole is around 67 south, 66 to 67 south, right? Which is nowhere near 90 south. But it is in close enough proximity to cause an anomaly, a pressure. Remember, opposing like poles repel, okay, which creates a pressure, okay, and that pressure it not only shows up, it shows up in the form of the Ring of Fire, for one, which is perfectly on one of these things. Oh, we're not sharing, are we?
Oh, okay, I just quit now. Now you can do it. I just put you up. So it's perfectly on this. Your Ring of Fire, all of your stuff is on here.
The Ring of Fire is on there because
Is the Ring of Fire what you've highlighted?
Everything is a product of the magnetic, all the weather patterns and everything that goes, they all match up. I just ran over my dog.
I'm sorry, Doji.
honey.
Dog.
Sorry, dog.
It's funny that both of you love Hawaii so much, and there's Hawaii in
Yeah,
the
right
center
on
of
the
the
flag.
heart-shaped
In
cleft.
our heart.
In our heart.
Yes.
Isn't Hawaii the home of the goddess of the earth?
Pele, yes.
Pele, yes.
It's the god of creation. In other words, that's the magnetic. It's the spot here. It's the international date line. It's where the international date line belongs, because each day the sun goes across around, and each time it takes off here, it switches our celestial plates on the moving clocks that we're on.
Yeah.
So again, take a planisphere and put your south poles here and here and make them duplicate moving both clockwise and this moving counterclockwise with your Polaris in the middle.
Yes.
Then
Now,
you can overlay every continent on the grid lines, which again come out that Australia is, I believe, I'm not doing a mirror image, but angled out that way. Like you said, it angled for the light, but it catches the light on the arc perfectly east-west for Australia. You just put the coordinates in it.
now
it
the
works.
implications of this, guys, is not only three magnetic central points on the Earth, but it also applies because as above, so below, there's a third object up there.
This is what I'm thinking from the diagram, because there's something we're forgetting when we're looking at the diagram. We're forgetting the POV.
Yes.
Oh, because they're describing this, say, hold on, this is only a 2-dimensional version, we're in a three-dimensional world, so there's something else that they can't depict because they'll be having to look through it to see what they're showing us.
And they had to roll everything by 60 degrees or 66 degrees.
They
Thus,
roll
that's
it
why
over
we
at
see
66 degrees.
that coordinate everywhere.
To hide it.
It's replete.
That's
it's
what you
everywhere.
have to adjust the map by the coordinate. If you draw in your map, Antonio, I want to play with you on the map. It's if you make these grid lines the right width, if you made these the right width underneath it, so it just got condensed a little bit.
Yeah.
I worked with the pattern with the magnetics there. These are you read the numbers, they are your coordinates. I can tell you where everything is placed accurately on the maps because things have to be accurate because people fly from place to place and they travel and they do things.
Yeah.
And we have it working if you do it here, taking the Tahiti Express, your magnetics are always going to pull you around here. I was telling Bob if you were going to hide land, where you would hide land is right up here.
Yeah.
Off of the map because you have sunlight past Hawaii, but all your magnetics pull you back around. Everything that you try to do, water, flying, or whatever, your things are going to pull you back in. But any hidden land, you have a temperate zone up off the chart, up here.
So
Wow.
this is where the hidden land would be if it was on this.
Yes,
Here.
yes, and then pull these back around there. Yeah. This makes an oval over it again. It's more condensed than this, but it's like the fattest egg you ever saw,
Right.
like a fat egg.
So one thing that we need to try and
the
confirm
sun thing.
is that the 2
How does
points of
that-
Antarctica that we're seeing that are basically diametrically opposed, I'll bet you that to get to each of the bases that would reside on each side of the Earth, one set of people would have to leave from like Ushuaia, roughly, and then others would have to leave from the vicinity of Australia. Okay, in other words, there is no shortcut to just go whipping across the continent, you know, because it's literally on the opposite side of the plane.
There's like
But
Australia.
they folded it in. They folded those two sides of it in, those two land masses into one point on Australia. That's where we've been missing it because everybody's been looking at the east-west and the secret's on the north-south.
They confused it. They spun it around.
The
All you have
object,
to do
the
is
third
overlay
object.
the magnetic map and overlay the magnetic poles where they both are on top of Russia and on top of us. It's the same pole. So that they doubled out the pole, and then by lying and imaging it doubling out on a piece of paper because the bottom poles do double out. There are two poles down there. That's why the quad pole map. That's why the quad pole maps always have Russia and America split like this.
Yeah.
Because taking it and putting here and here, so all the magnetics and everything on the quad pole are alike because these ones are folded together. You're taking it and you're taking the map and you're like they said in what was it, Jodie Foster? What was the primer? Contact. You know how you took it and you had to fold the primer? That's exactly what you're doing on this primer. The primer is you take the two north poles from Russia and bring them in.
Remember, they brought everything into the triangle. In the triangle, if you remember the primer, how they
They
came
have
on
to give us
contact.
the answers.
It's been right there in front of us the whole time.
They tell us the answers just to the wrong questions.
And the object in the sky, the third object that you said has to be there because of as above, so below could be what is responsible for the eclipse situation that nobody
is
can really
exactly
figure out.
I have the eclipses
Yeah.
figured out. Got it.
Yes.
Oh, okay, you do? Okay.
I have the eclipses totally figured out.
Wow.
So can I
So
just
what's
ask a
the
couple of
third
questions?
object, then?
Can I ask a couple of questions?
I don't need a third object. There could be a million objects up there, but I don't need it for any of my
Yeah, I'm
theories.
saying it's implied, and it could be that
He's
that
saying in
third object,
Trinity.
which could be considered to be Rahu or the Black Sun, that's been told in mythology.
Well,
Yeah, that's
that's
what I'm
one
thinking.
question down. The second question was, you said Antarctica is everywhere, but we've got these two magnetic bulges. What did you mean by when you said Antarctica is everywhere?
Because
Well, it's all around us.
if you
There is an ice wall.
there is an ice wall. As soon as you go out of the realm of where the sun can melt the puddle, so you have that egg-shaped, you have your egg-shaped, right? That the sun is going and it's going to melt that. So you're going to have ice sheets where there's no continent.
Right. So
But
one
you
last-
do have where there's magnets and that going, like where people get on and see ground and it's not just snow and not just an ice wall.
So, I've got,
So your ice walls are
one last
more
question
frozen.
then. So if you're
Yes.
in Hawaii, and
Yeah.
you've got, let me just wrap my head around this. If you're going north of Hawaii, you've got a different south Is that correct? When you're in Hawaii, to go further up the map?
Okay, when you're in Hawaii, follow your direction lines. You're at Hawaii, you're in the middle of the heart.
Yeah, directly down.
Okay, and Hawaii, what's famous in Hawaii is the Tahiti Express. Follow the lines, That's your direction. That's how you read direction. East, west, and that are these lines, and they change because they're compass lines. And as your magnetics change, your compass lines change. These are your fields that they follow.
What Nathan is saying, if you're in Hawaii and you're heading north and your compass is pointing north, what we call the South Pole would be behind you. So it would be in that space where you say that there could be another pole or another.
Yeah, where they have more land because there's more space. Here we are in Hawaii, right?
No.
They have nothing mapped
In
here.
Hawaii, you're at the top on the cleft.
Let me ask my question again.
You're
I'll
right.
ask a slightly different question. So if you're in Hawaii, if you're in Hawaii right now and you want to go up off the map, what direction are you traveling? If you go up to where you said there was more land, which direction are you going? If you go literally up
you
off
would
the
have to
map?
go straight here, but it wouldn't. Your compasses are going to want to take you this way and that way. They're not, and the currents, the Tahiti Express, all of the currents, all of the airflows, all of the jet streams, everything is taking you around here. So you have to break through that little. Everything is circling there. So where it would be hidden is making it through whatever the break is.
There's like a barrier there of some sort.
I don't know what it is, but all of your readings are going to circle you one way or the other, but they're not, your readings are circling you.
Right, because remember, when you're traveling by compass, there's always a declination factor, right? And I haven't checked this yet, but I'm wondering, what is the maximum magnetic declination? Is it like up to 33 degrees by any chance?
You would have to look it up.
Yeah, I need to check.
Yeah, I bet it is.
I'd almost bet you that it is.
Yeah.
I mean, this fits together so neatly, but it really is, conceptually, it messes with your head because, again, we've been taught everything backwards, reversed, and upside down.
Don't mean to be disagreeable,
So
but not at all. This conceptually works beautifully. I don't have to wrap my head around it at all. It seems to work perfectly.
Oh, that's awesome,
Yeah,
Nick, and I'm glad to hear that because it's taken her a long time to pound it through my head. But it clicked
so
today.
beautiful.
That's why I asked you guys, are you visual? It's like Africa sits on the thing right here with the prime meridian going right there. And again, you can, if you draw the lines and coordinates, you can match up where they go.
The prime meridian goes right down the Nile.
South America goes, once you hit the equator and that it's partially on here, it comes and it tips right around like this. But all you have to do is look at where the coordinates are on the map and draw the points on where the edges are, Antonio. Once you squish it in and you put points on where the coordinates, that tells you where everything is for your map. Do you understand? If you squish this in as a grid line,
Yeah.
I can help you read it if you have any problem reading maps because I'm good at it.
Okay.
I adjusted the grid lines on it for it. But if you do that, all you have to do is read your numbers, read the land coordinates, like on the tip of Brazil or like the tip of South America. Like South America's came out right, I believe, right here. It tells you where to put your dots to do the outlines of your continents.
Yeah.
Because your coordinates are all real. People travel the land. They're real.
Yeah.
Okay, so let's say that you placed the continent there now, and once you placed it, you then adjusted for that distortion in the spacing between the lines. Would
Right.
you
Very little distortion, yeah.
Yeah. Would you then reorient the actual landmass?
Yeah.
Yeah.
Yeah, and it tells you, it does it itself by matching up different cities and that, it tells you to use shell.
So I've got you, yeah.
It does it itself, you'll be amazed. It does it pretty accurately, even with wrong misshapen pieces that when you hold and do the paces over, it does it.
Does it explain things like the Bermuda Triangle with the magnetics and such?
Yes, it specifically.
Of course it does.
It specifically
the
addresses
anomalies,
that.
you better believe it does.
It addresses that, it addresses the
Okay, so
cosmetics,
what
the-
doesn't this explain?
I
aside from
can't
the
find
globe?
anything.
We haven't been able to
We
figure
haven't
out
been able to,
anything
we
yet.
haven't been able
That's
to
why
find
we're-
anything. If you can think, ask me a question that I can't explain on this.
Wow.
I know, it's overwhelming. It's like, wow.
Well,
So they have to
congratulations. I mean, pat yourself both on the back. I mean, wow, Jesus Christ, I'm lost for words. Wow.
I told you when I said I
We've got a
really said
primer,
I have
man.
the
We've got a
primer.
primer.
I have
That's
the
what-
primer.
Of all
Because,
people
I don't
to
want
figure this
like,
out,
Turks believe, but he says it's that what this has been like is this has been for like me. I'm a puzzle person, and I told him all of this past. I've been working on it for over a year, and I told him it's like a diagramless logic problem. That I don't know if anybody did Dell puzzles or anything, but I love logic problems where they to give you the sentence you had to figure out who lived in what house in the.
Mm-hmm.
Do you know what that is?
Yeah.
And then the diagramlesses are like the crosswords that they don't tell you where the blocks go.
Mm-hmm.
So this has been, I told him, it's like, this is like solving a freaking diagramless logic problem because you don't know what questions to fill in the diagramless one. Which ones are pertinent.
how long have you been working on this from the first
Over
time?
a
this
year. I have a solid working model of it in print over a year ago that had some of it, but not everything.
Of
Yeah,
all
she
people
basically-
to come up with it, Cami, you connected with Bob. I mean, thank goodness. Good, wonderful, warm, nice, loving, connected, conscious people. Like, oh my God, I feel like crying. So good.
It doesn't help me with Bob, actually. It's good to talk. I mean, I love Bob. No,
Believe me,
But it
Patricia,
broke up their marriage.
it's to her.
No,
No.
listen.
no, he's thrown this out over a year ago because
Yeah, but-
I'm his wife.
But Cami, please listen, okay? Because you have to explain it to Bob,
Uh-huh.
who has a very different mind to you, you have to conceptualize it more clearly for yourself so you can explain it for him.
You're right.
So if he had a mind that was closer to you, you might have a more vague idea and never actually come to fitting it. Do you get
So it's perfect.
Yeah,
I do.
yeah.
I do. But when I said I mean that in a good with him, it's just he does not have the visual. He has so many other skills, but he does not have.
Yeah. So you have to make it extra rotund so that, you know, it is digestible to some
Right.
Yeah.
visual.
So
And
just-
she basically came up with all this when, about a year ago, and I was saying, look, this has got to be a magnetic model. This, the magnetics is the key to this. She took that to heart and ran with it, and that's basically what she's been doing
Started
ever since.
studying theory. So I don't always watch all of the shows and everything in the background. I try to get on the chats, but I'm in the background looking at magnetic patterns and I go out and I watch the moon every day to do the phases. Patricia, do you want to know how the phases work?
Oh, she's
Yes,
got this
please.
down cold.
That's been something that's been bugging me bigger than almost anything involving all of this.
This I have proof positive, or not proof positive, but it's pretty good.
It pans out.
It pans out.
Yes.
Okay, I'm gonna share a screen. Let's see how well I can do this to you without the. Oh, you know what? I can do it in a picture here a little bit first. Let me do it here in color.
Okay,
I
so
was looking at the moon last night and it was
just a little thing to throw in. You
Uh-huh.
look at the sun, and the sun veers out until it hits that flux point where it bounces away and hits the other flux point. Okay. So there has to be flux points this way too for the moon
I know.
to go up, bounce off, and bounce back up.
Of course. Yeah, that's part of the field. That's the toroid of a field. It has to be there. You're right.
Are they seasons as it does that?
This does seasons. This does it all. Let me show you. Again, I don't have the artwork of the presentation done, but I have it in my brain. So, okay, imagine the sun's path, the yellow line, and the moon's path is the blue line. Now, I'm taking this from a picture of the sun and the moon's path out of all of the science. If you look up lunar nodes, you will come up with this picture.
Okay. And let me stop her right there. Hang on a second.
Okay.
And also to understand this, you have to understand that these two circles, as the year goes around, they're actually going like this, up and down. Okay? So you'll have the sun higher at some points, and you'll have the moon higher at some points. In other words, they're kind of teeter-tottering back and forth.
It's a
Okay?
monthly
That's
teeter-totter in
important to
there.
know.
The sun and the moon are teeter-tottering every month, and it creates the phases within the heights of the sun and the moon, but they're also expanding and contracting between the fields. So this is
As they
how,
ride between
as they ride between them,
the tropics.
as they ride between the tropics, this is how it works. Oops, I'm going to keep this color, the sun and the moon colors in your mind, and I'm bringing them on the screen.
So the map shape is egg-shaped, somewhat circular, with an ice ring.
Yep.
And maybe more land. We don't know.
Yeah,
Yeah,
possibly.
towards
Admiral Byrd
The
made
cleft above Hawaii.
The map shape doesn't have to be egg-shaped. The energy's egg-shaped.
Got it.
But there could be, this, like with the free energy generators, which have sequencing of magnets but have one slot empty, so that the magnets will not clog with the next.
Exactly.
Yeah.
Exactly, Antonio. You got it right on the money. That's what it is. It's literally a magnetic field that is being stepped through its phases.
Okay, let's view this image. You're gonna bring that up. Okay, remember the picture and how I had it?
Yeah.
So don't lose me. This is the sun, and picture for all practical purposes, picture the sun's path over your head flat, like on the same plane as you.
If I can just say, Cami,
Uh-huh.
Patricia, if you remove the globe with your mind, remove it from there and put the flat.
Get rid of this entirely and put a flat world underneath it,
Flat
with
world?
this being
Yeah,
the
underneath.
equator going here to here. So it's right
Okay.
now it's over the solstice, right? Flat line in the equator. Can you draw that so it's perpendicular underneath it on your flat world?
Mhm.
Going around the pole? So think of this just as your North Pole star.
Yeah.
Yeah.
Okay?
Good way to look at it.
Okay? Now, things to know about these orbits. First of all, and these are all scientific facts that we're just putting into motion. They just told you the wrong direction on everyone. First of all, these orbits are similar, but they're not exact. So think of a spirograph. Think of a spirograph where you're doing almost circular patterns that they'll lay on top of each other this way sometimes, and sometimes they'll lay like this is a little bit out of phase from it. And certain number of rotations in that, they will lay right on top of each other where you draw the same circle. Does that make sense?
Yes.
Okay, I need it to make
point
sense.
where they cross over, the two circles cross over.
Okay, so follow me, Patricia. Okay, now let's put you in the sun. It's noon where you are in Dallas right here, and you're right here, Houston. Okay, I put you in Dallas. I like Dallas better than Houston, I'm sorry.
I don't like either, so.
I like Dallas. I like Texas a lot. People are really, really nice. And I like San Antonio and Austin and that area more than
People are nice. This is true.
they're really, really nice. Okay, so your sun is right here, and it is noon. So it's over your head and everything, and right now it's the summertime actually. They really have it right above your head, right?
Mm-hmm.
Okay, so we're gonna pretend, and that's noon every day. It's always there at noon. So the sun is right here. So you're following me?
Yes.
When the moon is new, it's right here. And it's black. You have it underneath. The sun is illuminating or fluorescing the top part of it, and you're not seeing the bottom. It's washing out. It's blue. It's washing out in the sky, and it's right next to the sun in the sky as it's traveling around.
Which, by the way, is a property of celestine like you wouldn't believe.
Which is, by the way, this stone will, as it is exposed to radiation, turn more blue. The closer it is to the source, it's going to do more blue, and it will turn more white the further it gets away. Oh,
It's our favorite place.
it's where we want to, when we get this, or like, that's where we should all have a retreat there. Just live.
I think we should all go and hang out with Nassi.
It earns its nickname Paradise, believe me.
So that would be the ground, and the ground is what's doing this and that, right? Let's see if I can get this to do it for you. Okay, so a half moon.
Yeah.
A new moon.
Yeah.
A full moon. Oops, I'm holding it backwards. Because on the altitude, it's one directional. So you have full, and then as it goes around, you're going to get your crescents. If I was holding it directly, you get your perfect crescents coming.
Mm-hmm.
And notice, in order to do this, it requires a relatively close light source.
Yes.
Same with the
Otherwise,
sun.
it would just
Do you see how
bathed in the light, right?
From underneath, which I'm giving you guys the underneath view, from underneath you see the half and then the waning.
Right.
You can get the perfect crescents going on both sides. So waning and waxing getting higher and lower, but because of the fact that you're viewing it, you're seeing the below view. Here's your half moon, is crescents out perfect. It does it perfectly if you hold the light.
Something that you also need to know about this, guys, is that
almost a full
the
moon.
sun is not reflecting the light. The sun is fluorescing the moon. And that
Yeah, I was just gonna say, that's
Right,
where
that's
they
what-
get that from, the
Yeah, look, Nathan.
half story.
Yep. It's the
No.
that's why
It's making it. I have the wet and the fluorescent lights in it. It's actually making it glow. Like phosphor, like when you put these minerals in a light box.
Oh my
you guys
God.
see minerals in a light box. So it can't
Look at
cook
that.
all of it. So when he does half,
right.
I'm
it's
sorry,
actually
to be really stupid. I don't understand what you're saying. So,
Right.
what you're saying is the moon. What are you saying is the sun? I don't get
Oh,
it
here.
at all.
Let me
let's
Okay.
show
Nathan,
let's
I'm
do
going
it
to have
this way.
him do it for you.
Let's show this.
I'm going to
Alright.
go smoke. I'll be back, boys and girls.
Okay, Nathan.
Okay, Nathan, so
What they have is a stone called celestite, which has really peculiar qualities. That is highly magnetically impermeable, and it reacts to radiation. Depending on the type of radiation, it will give a different color light.
correct.
Will
Yeah,
have
I got all that. What I'm saying is, are you proposing to me that there's a giant ball of that stuff that you've just held up balanced on a magnetic field?
That is exactly what we're proposing, yes. And it not only does, when you look at it close, it does not look like celestine, but celestine has all the characteristics that you would expect, including this. Here's the sun, and it's not visible light, okay, that's fluorescing the moon. It's the radiation, just like that. Same principle, exactly. So the moon is self-illuminating, but get this, when the moon illuminates, it illuminates just like this light does in a cool fluorescent light. A cool light,
yeah.
right?
Cool.
And
So-
when you think in terms of that much bulk being held up there, if you start to think instead of the amount of force needed for the boundary or the firmament to be up there, there's more than enough force for something
Well,
to be
you
up
say
there.
that much bulk, Antonio, but I've been slowly edging towards it being much, much, much closer and much, much, much smaller. What do you think, Bob?
You know, I can't disagree with that. It's funny because I was talking to Robert Bassano of all people yesterday about that. You know, and because he was making his assertions that he thought, actually he uncovered some documentation that was saying that the moon is like yeah, much, 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 much closer, like, you know, somewhere just over the 100-mile mark, which
That's exactly what
think-
I said. I said if you lay out a couple of thousand miles, which is a huge, vast distance, and then tip it on end, is that the distance you see between you and the moon? Absolutely not. If you were to lay out about 100 miles and tip it on end and look at the moon, just looking at it, it looks about 100 miles up. That's what it looks to me.
It kind of looks that way, and honestly, the only thing that doesn't make sense about that to me is when you do the Pythagorean triangulation on it, it comes out to be a little over 3,000. So I can't explain that unless it has something to do with the point of reference that you're taking those readings on the moon on, because it is 33 miles across after all.
Could it be as simple as, instead of it being 100 miles, it's 300 miles, and the extra zero was just thrown in there as a value?
No, I think it's much smaller than 33 miles. I don't think it. I mean, for that rock you just held up, Bob. I mean, let's be realistic. No matter how magnetic it is, it can't be massive. No matter how big the forces are, it's got to be relatively small to bob along on these magnetic forces. So it can't be massive. It just can't be.
Well, it doesn't have to be massive, because one thing that I can tell you about geoids, or this particular celestine, it is a geoid that grows with a hollow center. In other words, it's hollow.
Ah.
And remember,
okay.
NASA's even given us those hints. They said, yeah, well, we hit the moon with something and it rang like a
It rang
bell.
like a bell. Yes.
And that is exactly what would happen if you had a geoid of this and hit it, it would ring like a bell. This has all the properties that responds electromagnetically and photooptically to the long wave ultraviolet, to the short wave ultraviolet spectrum. It responds to all of those. It is also temperature, I forgot what you call that term, but it also responds via temperature on its luminescence as well. So, I mean, this has when you really look at the characteristics of celestine, it has everything we're looking for. When you look at the C's, and the mares, Maricris and stuff like that, what you're actually seeing is you're seeing the facets of this stone. And here's another interesting part about celestine, is if you put it in water, it will slowly but surely decay, but it decays in perfect circles, perfect little crater-like circles.
With
Right?
Exactly.
With a
Like-
small divot in the center.
Huh?
With a small divot in the center.
Yes, it can do that too. And you can actually see that in this particular stone. I don't know if you can get the resolution on this, but yes. So when you examine the surface of this piece of celestine, and you also examine the facets and look at the moon and just kind of imagine it scale up, it's a match. But like I said, the beautiful part about this is that it fluoresces sky blue during the day, which is just exactly what we see on the moon.
In the day, yeah.
And
Yeah.
Wow.
grey patches.
Yeah, and the gray
Yes.
patch, the whole 9 yards. It's exactly what you see in this.
And it's
So-
celestine or celestite, I guess it has two different names. And I was just reading right now that it says it has some strontium has that. in it.
Yes, yes, it does.
Okay, well,
And that-
the next thing I've got a slight issue with is still hollow or otherwise is bobbing a giant spherical rock on a magnetic field. I mean, don't get me wrong, I've seen the magnetic stuff do its stuff, but I mean, do you think? I mean, I know we see the moon doing this, so obviously there's something there doing that. But do you think it's something we could replicate in small scale?
John Hutchison already has done.
Yes,
Yes.
yeah, exactly. Hutchison. And the other thing, Nathan, is that, like I said, if this is indeed in some sort of liquid, like space is in a liquid,
Plasma.
depending on the viscosity of what that liquid is, this could also be floating a little bit.
I'm with Cami
You
on
know,
plasma,
that-
sorry.
that's
Plasma.
okay.
Plasma.
Wouldn't eventually because it disintegrates in water, wouldn't eventually, if space is water, the moon disintegrate? Or is
Well-
it not in the watery area, the water is above that?
No.
Not sure, but what I can see, that's why I wanted to see how old or how far back we could get old pictures of the moon and see if there are any very slight changes in it.